Okay, so chapter 19, what is the subject of chapter 19? Circuits, electric circuits. And so an electric circuit is what we find inside an electronic device. For example, inside our radio, in a car, in our computer. Okay, so that's going to be what we are going to be studying, these electric circuits. What kind of electric circuits? Just the ones that have steady current. Remember that we talked about steady current is when we have this constant flow of electrons. It doesn't increase, it doesn't decrease, it's steady. And we are calling these circuits DC circuits. DC, remember, it means direct current. So we are not playing here with AC currents, just DC currents. All right. Now, what is the idea of having an electric circuit? We want to turn on some device. We want to turn on our radio, our hair dryer, our computer. And how we are going to do that? We need current to be flowing through this circuit, which will then be able to power to turn on our device. And what do we need to have this current? We need a battery or a generator. We'll be talking about batteries throughout this chapter. Okay, so the battery is what is going to provide us with a potential difference. The potential difference will then let the electrons flow through the circuit. Okay, all right, so now there is something interesting in this story. The battery, as we already discussed in chapter 18, the battery, what is it? It's a chemical reaction. So we transform this chemical energy into electric energy. In this process, the battery is trying to provide us with a certain potential difference. This potential difference that is coming from the chemical reaction is what we'll be calling this EMF, which stands for electromotive force. So this is the potential difference in a way that the battery is trying to provide us with, and we are going to indicate it with this fancy E. So let me write this here. This is what the battery is trying to give us. Okay, so the battery is trying to give us this potential difference, which we are going to be indicating with this fancy E. So let me call this potential here. This is the region of the high potential, right? I'll call it this V1. And this is the region of the low potential, which I'm going to call it VB. So this fancy E is the EMF, which is in a way the potential difference that the battery is trying to provide us with. So is this V1 minus VB. Okay? All right. But what is the issue? As the electrons start to flow, still inside the battery, they are going to find a little resistance. Okay, so this is the little resistance that is inside the battery. As a result, as we already talked, every time we go through a resistance, there is a drop in the potential. So still inside the battery, the potential is going to drop and it's going to become a certain VA. All right, after that, we are out in our circuit. Okay, so after that, we are out in our circuit, and then we'll try to turn on some devices. No, this could be our radio, could be our lamp, whatever device, the hair dryer, whatever device we are trying to turn on. Okay, but what is the main point of this story? The battery was trying to, through its chemical reaction, was trying to give us this potential difference. But what is it that we actually can deal with? What is it that our battery actually gives us? This smaller potential difference, VA minus VB. Okay, so what are we going to be able to use? What is the potential difference of the battery? VA minus VB. Okay, what was going on inside the battery? What was going on inside the battery was this V1 minus VB. But that's not what we're going to be able to make use of, because inside the battery there is some resistance. Okay, so this is what this slide is trying to tell us. The potential difference that we will get, that our battery will provide us to turn on our device, is what was coming from that chemical reaction minus this little drop caused by the resistance that is inside the battery. Okay, so what we'll have to have is the potential difference of the battery, which is that VA minus VB, is the EMF minus this drop caused by the little resistance inside the battery. So that's what we'll have to play with. All right? Okay, so given this, let's try to see a problem to hopefully things will become a little more clear.